Okay, today we're going to talk about how electrons are arranged around the nucleus. We know they're hanging out in this part of the atom called the electron cloud, but today we're really going to figure out how they are arranged. And there's quite a bit to this, so please have your guided notes out, your Chapter 3 guided notes. Be filling them out. We can go through a little bit of notes, and at the end we got a bunch of practice problems to see if we can learn this new concept. Okay, so the concept that we're really going to focus on is called electron configuration. It's one of the vocabulary words for this chapter, and so electron configuration is the arrangement of the electrons in the atom. It just is a way for chemists to write down in a concise way how the electrons are arranged around the nucleus. We're also going to learn that electrons are arranged by orbitals. We'll talk about 4 different orbitals. We're going to talk about energy levels in this video, and briefly introduce electron spin, although we'll focus more on electron spin next time. Okay, so orbitals and energy levels. We're going to hit that in this video quite a bit. So an orbital is a region around the nucleus where there's a probability of finding an electron. So probability, if you think about the word probability, it means the likelihood or the chance of finding an electron. And so that's really what an orbital is. It's this space around the nucleus where there's a high probability of finding an electron. As we learned in the last video about the Heisenberg uncertainty principle, we don't know for sure exactly what its position is and its velocity, but we're going to talk about it in terms of orbitals, the probability of finding an electron in that space. Okay, so let's show you exactly what an orbital is. So an orbital's shapes are defined as the surface that contains 90% of the total electron probability. And so this diagram at the body, this density map, kind of gives us a good idea of how they come up with the shapes of these orbitals. Now, if you were to draw a circle around this is the nucleus, if you were to draw a circle and these blue dots are the electrons. So if you were to draw a circle around and you wanted to contain 90% of them, well, this is where the boundary would be. And so this black line right here, which is now red, would represent the orbital, which means 90% of the time the electron could be found within that orbital. And that means, of course, that 10% of the time that electron might be outside of the orbital. And so that's how they come up with the shapes of these orbitals that we're going to talk about today. So it's really just a probability map, where 90% of the time it's likely that the electron would be found within that shape. Okay, we're also going to talk a lot about, in this video, energy levels. Electrons move around the orbitals in different energy levels. Each energy level is given a number called a principal quantum number, and it's given this symbol lowercase n, and it indicates the relative size and energy of an atomic orbital. And so I've got a diagram that kind of explains this. But we've talked a lot about the Bohr model of the atom, where Niels Bohr said the electrons are traveling around the nucleus in these circular paths called energy levels. And so this would be the first energy level, the second, the third, and the fourth. As you get farther away from the nucleus, you get more energy. So the fourth energy level has more energy than the first energy level. This first energy level is the lowest energy. Okay. They call it the principal quantum number. And so this principal quantum number, this first energy level, why do they call it a principal quantum number? If you remember from last video, we talked about what a quantum was. A quantum is the minimum amount of energy that an electron the atom must gain in order to move the electron up to a higher energy level. So it has to gain or absorb a specific amount of energy, and that's called a quantum. And then as it falls back down, it gave off light. And so if you remember from the last video, anyway, that's why they call it a principal quantum number. Okay, so we're going to talk a lot about energy levels. And so the number of electrons that can fit inside a shell is given by this formula here, 2n squared. And n is your energy level, or principal quantum number. So we're going to use that formula to determine the number of electrons that can fit in that energy level. Okay, practice problem number 14. I hope that you're following along with your guided notes. And let's do practice problem 14. It says the number of electrons that can fit in each energy level is given by this formula, 2n squared. And it has part A, says how many electrons can fit in the first energy level. Okay, n is equal to 1 is the first energy level. Well, let's plug it into this using this formula. We've got 2. Our n in this case is 1, the first energy level, and we've got to square that. So 1 squared, 1 times 1 is 1, times 2 is equal to 2 electrons. 2 electrons can fit in the first energy level. Okay, and we'll see that as we work some problems today. Part B says how many electrons can fit in the second energy level. So the n equals 2 energy level. So let's plug into this formula again. 2 times, now n in this case is 2, and we're going to square that number. So 2 times 2 is 4, times 2 more is 8. So there's 8 electrons that can fit in the second energy level. Okay, part C. How many electrons can fit in the third energy level? So now we're in the third energy level. Let's again use this formula here. 2 times, now in this case the n is equal to 3, and we've got to square it. 3 times 3 is 9, times 2 is equal to 18. So there's 18 electrons that can fit in the third energy level. Okay, now we're going to move to atomic orbitals. Energy sublevels, or electron orbitals, are contained within the principal energy levels. So in your guided notes, there's a spot for you to write this information down. And it says for the n equals 1 sublevel, or for the n equals 1 energy level, there's 1 sublevel. There's 1 sublevel for the s orbital. So this letter here is the orbital. So there's an s orbital, which we'll talk more about in just a second. For the second energy level, there's 2 sublevels. So it shows in the first there's just 1 sublevel. In the second energy level, there's 2 sublevels. And there's 2 orbitals. There's an s and a p orbital. Okay. For the n equals 3, so the third energy level, there's 3 sublevels. For the s, the p, and the d orbitals. For the fourth energy level, now there's 4 sublevels, and you've got an s, p, d, and f orbital. So please make note of that. There's a spot for you to write that in your guided notes. Okay, so we've learned that there's 4 different orbitals. There's an s, there's a p, there's a d, and there's an f orbital for these electrons to fit in. And we're going to go through in the coming slides and explain each one of these individually and in more detail. Each energy level, or each energy sublevel, relates to orbitals of different shape. So this is just a diagram that shows all the different shapes of the orbitals. So this is an s orbital, the p, the d, and there's also f that's not shown on this diagram. So we're going to break this down and go through each orbital individually. Let's start with the s orbital. The s orbital has a spherical shape. So that's kind of easy to remember. S, And spherical, start with an S. So it's a spherical shape, centered around the origin of the nucleus in 3 axes of space. So yeah, we live in 3 dimensions. You've got an X, a Y, an X here, here's an X, the horizontal, the Y is the vertical, and a Z axis would come straight out of the board and straight back into the board. And I can draw that on a 2-dimensional board, so I'll pretend that this dotted line is coming straight at you and straight back into the board. Okay. And it wants you in your guided notes to draw an S orbital. So you draw your X axis, your Y axis, your Z axis, and the S orbital is just a circle. So if this cross right here represents the nucleus, the S orbital is a spherical shape. This looks like a round sphere. Okay. And again, let me emphasize this. An orbital is where 90% of the time that electron would be found within this spherical shape. Okay, let's look at the p orbital. The p orbital, there's 3 p orbitals. Okay, one of the p orbitals goes on the x-axis, like this one here, and it looks kind of like a figure. It makes kind of this figure 8 shape, or it looks like a dumbbell sort of shape. So there's one on the x. There's a p orbital on the y-axis going up and down, and there's also one on the z-axis, which would be coming straight out of the board and straight back into the board. And so that's what the p orbitals look like. Yeah, like it says here, the p orbital has a dumbbell shape, and there's 3 of them. There's 3 p orbitals centered around the nucleus on the x, y, and z axis. So I think it asks you to draw that in your guided notes. Draw the p orbitals. So here's my y, here's my x-axis, and this would be my z-axis coming straight out of the board. So let's do the one on the x-axis first, kind of just draw a figure 8. The one on the y-axis, again, kind of a figure 8. And the one on the z-axis I'll draw in dotted line, which will be coming straight out of the board and straight back into the board. And so that's how I would draw the 3 p orbitals. Okay, now there are d orbitals. There's actually 5 d orbitals. But in this class, I'm just not going to require that you draw them. They get pretty complicated, and I think it's beyond the scope of an introductory chemistry class. So we're going to know that there's d orbitals, and we're going to talk about the electrons that can fit in a d orbital, but I won't require that you draw them. So they're a bit more complicated, like it says here. Okay, and there's also f orbitals. There's actually 7 f orbitals. I'm not going to require that you draw them, and so just be aware that there are f orbitals. Okay, this is a good table that just shows you the energy levels, the orbitals, and the number of electrons that can fit in that energy level. So I want to briefly, it's not in your guided notes, but I briefly want to kind of go over it. In the first energy level, there's just an s orbital. There's only one s orbital, and there's 2 electrons that can fit in that s orbital. Okay, in the second energy level, there's an s and there's p orbitals. There's 1 s orbital, there's 3 p orbitals. 2 electrons fit in the s, 6 can fit in the p. Okay, and then as we work ourselves down, there's in the third energy level, there's s, p, and d orbitals. There's only 1 s orbital, 3 p's, 5 d orbitals, 2 electrons in the s, 6 in the p, and there's 10 electrons in the d. And if we look down here at the fourth, the f orbital, there's 14 electrons that can fit in those f orbitals. Anyway, this is something that we'll learn. I just wanted to introduce it here. But not a big deal if you don't understand what it's saying right now. We will. Okay, there's some rules to writing electron configurations. And I'm going to go over them briefly here, and we'll talk about them as we finish up the chapter. This rule, the Aufbau principle, states that each electron occupies the lowest energy orbital available. To be more stable, it likes to be closer to the nucleus, and they're going to occupy those lower energy levels first. And then they'll kind of work themselves out away from the nucleus. So we're always going to start filling the electrons in the 1s orbital. Okay? And then we'll go to the 2s, and then 2p, 3s, 3p, and just so forth and so on, all the way until we get farther away from the nucleus. This will also make sense as we go through some example problems. But Aufbau, just remember the lowest energy levels first. Okay, there's this rule called the Pauli exclusion principle, which states that a maximum of 2 electrons can occupy a single orbital, but only if the electrons have opposite spins. Okay, so a couple of important things here. 2 electrons in an orbital. So how many electrons can fit in an orbital? The answer is 2. 2 electrons per orbital. And they have to have opposite spins, which is something we'll talk about later on in this chapter. Okay. So Pauli exclusion principle, 2 electrons per orbital, and they have opposite spins. Okay, let's talk about the last rule for writing electron configurations, and that's Hund's rule. And it states that single electrons with the same spin must occupy each equal energy orbital before additional electrons with opposite spins can occupy the same energy level orbital. Okay, this is something that we're not going to focus on in this video, but in the next video this will be talked about when we do orbital diagrams. So Hund's rule, just kind of leave that one to the side for now. We'll talk about it later. Okay, so we got the Aufbau, the Pauli, and the Hund's rule. Okay, electron spin. The electron spin describes the behavior or the direction of the spin of an electron within a magnetic field. Possibilities for electron spins is either plus 1/2 or minus 1/2. So they spin in opposite directions. They can either spin one way or the other way. And we'll talk more about electron spins and how that comes into effect next video. Okay, I've got a picture here of a periodic table, and I want you guys to take your periodic table and I want you to color it up just like this one. Okay, so I'm going to go over it real fast on how you should color it. You need 4 colors, 4 different looking colors. I picked blue, red, green, and orange. You can pick whatever colors you would like, but hopefully they look distinctly different from each other. So 4 colors. And the reason for that is we've got 4 orbitals. We've got the s orbital, the p, the d, and the f orbitals. So what I would like you to do first is just take your periodic table and I want you to color this part of the periodic table, so these first 2 vertical columns, and also helium over here. Don't forget this one. Helium and these first 2 vertical columns on your periodic table, I want you to color it a certain color. I colored mine blue. If you want to do that, great. Okay, so color all of those elements a certain color. Okay, and once you're done with that, I would like you to take this block of elements, and color it a different color. I colored mine red. If you want to color it red, great. Okay, when you're done with that block of elements, we're going to color this block of elements a different color. And then finally, I want you to color these bottom 2 rows on the periodic table. I want you to color them a different color. And then I would like you to make this key at the bottom. Okay, so whatever color you colored these elements right here, this is the s orbital. Okay, and this block of elements is called the p orbital. So make a key that corresponds to the color that you colored those elements and put p orbital. This block of elements is called the d orbital. So everything within this area on your periodic table is colored a certain color, and call it the d orbital. And then finally, these last two rows on the periodic table, they are the f orbital. So make your key at the bottom, please. That's a very important part. All right? And then I would like you to number put some numbers to this periodic table. And these numbers are given right here, and they are the energy levels. So the first energy level right here is this whole horizontal, this first horizontal row. That's the first energy level, all the way across. So it's just hydrogen and helium over there. Okay, then put a 2. The 2 corresponds to everything in the second row. So from lithium all the way down to neon. That's your second energy level. And it just keeps going down. And so 3, 4, 5, 6, and 7 are your energy levels. Okay, but then be careful. I would like you to label the energy levels for this block of elements, your d orbitals. It goes 3, 4, 5, 6. So notice, it was a 4 in the s orbital, but it drops down when you go to this d orbital, drops down one energy level to the third energy level. So 3, 4, 5, 6 goes here. And then finally at the very bottom, for this f orbital block, this is the fourth energy level. And the fourth energy level all the way across horizontally. And the fifth energy level is for all of these elements. The very, very bottom row is the fifth energy level. So if you will color up your periodic table, I'm going to hit pause and give you a chance to do that. So please hit pause on your video. When your periodic table looks like this, then hit play and we'll continue on. Okay, so hopefully you've colored up your periodic table and it looks like this, and you've also got these numbers which correspond to the energy levels written to the side, where like mine is right now. Okay, and then I want you to add a couple things to your periodic table. Up here at the top somewhere, or maybe at the bottom, you might have a little more room. And so I would like you to write a couple things. There's one s orbital, and it has 2 electrons in it. Okay, one s orbital, and it has 2 electrons. Somewhere else where you have room, I want you to put this. There's 3 p orbitals, and they have 6 electrons in them. So all 3 p orbitals can hold, each one holds 2 electrons. So 2 times 3 is 6 electrons. So each orbital holds 2 electrons. So because there's 3 of these p's, it holds a total of 6 electrons. Okay. Maybe it's not good to write over the top of that. I also want you to write this on your periodic table somewhere. There's 5 d orbitals. And they hold, there's 2 electrons per orbital, so a total of 10 electrons. All right? And then finally, there are 7 f orbitals. And if each orbital can hold 2 electrons, there are 14 total electrons that can be fit in the f orbitals. Okay, so if you've got that on your periodic table somewhere, all of this information, then we can get started doing some of these practice problems. But before I start, let me go through what this means. This is the s orbital block. Of course, mine was blue, so it says there's 2 electrons in there. Well, if you count across each horizontal row, so this would be 1 electron, each box on the periodic table corresponds to 1 electron. So this is 1 electron, this is 2 electrons over here with helium. Again, this is an s orbital. There's 1 electron, 2 electrons. 1 and 2. And so that's why this s orbital block is 2 elements across, because there's 2 electrons that can fit there. Okay, let's go to the p orbitals. There's 3 of them, so 6 electrons can fit in the p orbitals. Well, if you look, this is our p orbital block. I colored mine red. And if you count across, there's 1, 2, 3, 4, 5, and 6 elements across. And that's because each box on the periodic table, you just add another electron. And so that's why there's 6 across right here. Okay, let's continue this. The d orbitals, there's 5 of them. So it holds 10 electrons. So if you look at the d orbital block of elements right here, if we count across 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And that's why there's 10 elements across in this block, because they can hold 10 electrons. Okay, and then finally, the f orbitals can hold 14 electrons. And so if you look down here where the f orbital block of elements was, let's count across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's why there are 14 elements across in this f orbital block. And so you kind of get a sense of why or how the periodic table is arranged the way that it is. And this will help us write electron configurations that we're going to do. Okay, so if your periodic table looks like this, we're ready to move on. Okay, so when writing electron configurations, you're going to use the following form. Okay, we're always going to use this form. You have a number, you have a lowercase letter, and then you have an exponent above that lowercase letter. So you have an exponent. So let's talk about what each of these mean. The energy level is denoted with this number here. So this would be the first energy level. So the number out front tells you the energy level. The orbital is given with this lowercase letter. So this is an s orbital. It could also have p, d, or f orbital. So any of those letters could fit right there. And then the number of electrons that fit there is given as the exponent above the letter. So there would be 2 electrons here. Okay, so somewhere on your periodic table, it would be a good idea to write this information down. Okay? This is the form that we're going to use to write these electron configurations. We're always going to write the electron configurations starting from the 1s1, and then we're going to fill them from left to right and down, just like reading a book. I'm going to say that a lot. We go from left to right and then down. Just as you read a book, you start on the left side of the page, you go to the right, and then once you complete that line, you move down. So we're going to fill the electron configurations just like that. And it will make sense. What I'm saying here will make sense in just a few moments. Okay, so I've got a number of practice problems for us to try. I promise if you stay with me, you will catch on. Okay, I'm going to go slow. We're going to go through it. But you're going to learn how to write the electron configurations for every element on the periodic table. And you will be expected to do that for the test. So I've got practice problem 15 all the way to 21. And each practice problem has an A, B, and a C part. So let's start. Practice problem number 15. It says, write the electron configuration for the following atoms. 15 part A, we're going to write it for hydrogen. So I'm going to point out where on the periodic table hydrogen is. It's the very first element. And then we're going to write the electron configuration. Remember, we start with the energy level. So we're in the first energy level. So I'm going to write a 1. Which orbital are we in? Because that's the letter. This corresponds to the s orbital. So we're in the s orbital. And how many electrons can fit in the hydrogen atom? Well, there's just 1 electron because this is the 1s box. Okay? So this is how you write the electron configuration for hydrogen, 1s1. And I really want to emphasize, what does this mean? Why do chemists write electron configurations? Well, if we were asked to draw the hydrogen atom, we have the nucleus. And then in this first energy level, it's an s orbital. S orbital is spherical in shape. And so you draw this sphere around the nucleus. And we know that there's one electron in this electron cloud. So we draw the one electron. 90% of the time it's going to be found within this spherical shape. So, instead of drawing it, which will become very messy as we get to larger atoms, as you can imagine, if we get 100 electrons here, that's going to get very complicated to draw. Chemists will write the electron configuration to help communicate how the electrons are arranged around the nucleus. Okay, let's continue on. This will make sense as we go through a few examples. I'm sure you'll catch on if you stay with me. Okay, we're still on practice problem 15, but now we're going to do part B, which is helium. Okay, helium is over here on the periodic table. So if you remember the form for electron configuration, we need the energy level first. This first energy level goes all the way across. So this 1 right here tells us we're in energy level number 1. What orbital are we in? Well, we're in the s orbital because it's still blue. So the s orbital. And now how many electrons? Here's how you count the electrons. You always start from the beginning of the orbital. So this box represents 1 electron. And the helium box would represent 2 electrons. And so we put 2 up there as an exponent. Okay. And if you ever want to check yourself, you can just add up all the exponents. That should be the total number of electrons in that atom. If you look here, helium's atomic number is 2, so it's got 2 protons and 2 electrons. And so that's where these 2 electrons are. Okay, so if we're going to draw it, here's the nucleus. We have an s orbital, and we have 2 electrons in there. Okay, so you have 2 electrons within that orbital. All right. Let's continue on. Practice problem 15. Now we're on part C for lithium. Lithium on the periodic table is right here. Okay. So now we get to emphasize the Aufbau principle says we need to start from the lowest energy level and fill it until we get to lithium. So I know it's in the second energy level, but we can't just start with the second. We're always going to start with the first energy level. So 1. Which orbital was in this first energy level? Well, it's an s orbital. How many electrons? 1, 2. So we fill it until we get to lithium. So it's got 2 electrons. Okay, now we're reading it left to right. We're all the way done with this first row. So now we go down, just like a book, just like reading a book. So now we come down. We're in the second energy level. Which orbital? Well, it's still that blue color, and for me that corresponds to an s orbital. And how many electrons? Well, this is the first element, the first box here in the s orbital. So this would be a 2s1. And so this is how you write the electron configuration for lithium. Okay, a little bit tricky there, I know. Here's how you can check yourself. It's got 3 electrons. It's got 2 of those electrons in the 1s orbital. And it's got 1 electron in the 2s orbital. So if you add them together, 2 plus 1 is 3. And so if you were asked to draw a lithium atom, here's our nucleus. We have a 1s orbital. It's spherical because it's an s. We've got 2 electrons in there. But we also have 1 electron in the 2s orbital. 2s is a little bit farther out, and the electron will just be found within that. Okay. Hopefully this is kind of making sense. We're going to go through a lot more. Practice problem number 16, part A. This one is for beryllium. Beryllium on the periodic table is right here. So hopefully you've got your periodic table out. Let's look and see how we do this. We always fill from the lowest energy level. So we're always going to start with a 1 here. It's the s orbital. And there's 2 electrons, 1, 2, that can fit in that first energy level. Okay, now we're done with the first one. Come down just like reading a book. We're in the second energy level now. We're in the s orbital. And now we count over. 1, 2. So there's 2 electrons that can fit in the 2s energy level. Okay, that's it. That's it for beryllium. If you want to check, it's got 4 electrons, 2 in the 1s orbital and 2 in the 2s orbital. So if we're going to draw it, here's our nucleus. We have a 1s, there's an electron, there's an electron. There's 2 electrons in the 1s, and there's 2 electrons in the 2s orbital. So that's what it would look like. Okay, very good. I want you, well, actually, let me explain this one, because it does throw in a little bit different trick to this one. So let's do this one together. So practice problem number 16, part B, we're going to do for boron. Okay, boron on the periodic table is right here. We always start from the very beginning. We're in the first energy level, the s orbital. If we count across, there's 1, 2 electrons. Remember, each box holds 1 electron, so there's 2 electrons in the 1s orbital. Okay, now we're done with that first row. Let's come to the second row. We're in the second energy level. This is the s orbital. Mine was blue, so it's still the s orbital. And 1, 2 electrons can fit in that orbital. Okay, now there's this big space here. So we're going to come all the way across. We're still in the second energy level, so you always go left to right, just like reading a book. And we come to this point. Well, we are still in the second energy level, so we need to put a 2 right here. But now we're in a different orbital. This corresponds to the p orbital. So we're going to put a p right here. And this is the first box in the p orbital, so that's just a 1 electron. So 2p, and you put a 1 right there. Okay, that would be the electron configuration for boron. If you want to check yourself, remember that the exponents tell us the number of electrons. So 2 plus 2 is 4, plus 1 more is 5. And that's how many electrons boron has. Okay, now let me draw this one. So if this is the nucleus, we've got a 1s orbital with 2 electrons in it. We've got a 2s orbital with 2 electrons in it. But now we have a p orbital in the second energy level. Remember, the p orbital looks like a figure 8 or a dumbbell. We just got 1 electron in there. So that's how you would draw the boron atom. All right, practice problem number 16, part C. I want you guys to hit pause on the video and try to do this one on your own. See if you can get this one right. Just try it. You might get it wrong. You might get it right. But just try it, and then once you have an answer, once you have written the electron configuration, hit play and see if you did it right. Okay, oxygen is found right here on the periodic table, but we need to fill it starting from the very start of the periodic table. So we're in the first energy level, s orbital, and we have 1, 2 electrons. So we put a 2 right there. Now we come down to the second energy level, so we need to put a 2. We're in the s orbital still, and we've got 1, 2 electrons in there. Okay. Then we come across. We're still in the second energy level, so we need to put a 2 again. But now we're in the p orbitals. And if you count across 1, 2, 3, 4, we've got 4 electrons in the 2p orbitals. All right? And so if you've got that, you did it correct, because that is the electron configuration for oxygen. Okay, so if you were asked to draw it, we've got a nucleus. The 1s has 2 electrons. The 2s has 2 electrons. And this time we've got 4 electrons in the p orbital. So we've got 1 orbital on the x-axis, 1 on the y. And each orbital holds 2 electrons. So there's our 4 electrons in the p orbitals. Okay, I'm not going to expect that you draw them. I'm just trying to show you this is what it would look like. This means the same thing. So chemists will like to write an electron configuration like this. It's a lot simpler, cleaner, and it means the same thing. As we're going to see, as we get up to elements, you know, you're going to have over 100 electrons. It's going to be very messy to draw where all the electrons are. So we write electron configurations. Okay, let's go on to practice problem number 17, part A. This one wants us to write the electron configuration for carbon. Carbon is right here on the periodic table. So again, I would like you to hit pause, see if you can do write the electron configuration for carbon, and hit play when you're ready. Okay, carbon, we're always going to start at the first energy level, s orbital. There's 1, 2 electrons that can fit in that first 1s orbital. Okay, we're done at the first row. We come down left to right just like a book. We're in the second energy level. We're in the s orbital still, and we've got 1, 2 electrons. Okay, now we're done there. We need to come across. We build it up until we get to the element that it's talking about. So we're still in the second energy level, but now this is the p orbital. And we've got 1, 2 electrons in that p orbital. Okay? So that is the correct electron configuration for carbon. If we want to check it, we got 2, 4, 6 electrons, and carbon does have 6 electrons. Okay, so we just, whatever element it's talking about, we just build the electron configuration until we get to that element. Hopefully this is starting to make sense. Okay, let's go to part B, nitrogen. I would like you guys to try this one. Hit pause on your video, write the electron configuration, then hit play when you have an answer. See if you can get it right. Okay, nitrogen is right here on the periodic table. So let's build the electron configuration until we get to nitrogen. We're in the first energy level, s orbital, and there's 1, 2 electrons in the first orbital. Okay, we're done at the first row. Let's go to the second energy level. So I put a 2. We're in the s orbital, and we've got 1, 2 electrons there. Now we come across, just left to right, just like a book. Now we're in the p orbital, but I need to put that we're still in the second energy level. Whenever you change orbital, you still need to put the energy level. Okay, so we're in 2, and now we're in the p orbital, and it looks like nitrogen is 1, 2, 3 over, so we're going to put a 3 right here. That is your electron configuration for nitrogen. If you want to check, 2 plus 2 is 4, plus 3 more is 7. There's 7 electrons in nitrogen. Okay, very good. Let's go to part C for neon. Again, I would like you to hit pause, try it on your own, and then hit play once you have an answer. Okay, so neon is right here on the periodic table. Let's build its electron configuration until we get to neon. So we're going to start from the very beginning, the first energy level. We're in the s orbital, and we got 1, 2 electrons. Okay, now we're done with that first row. We come back down and then go left to right again, just like a book. We're in the second energy level, still the s orbital, and we're 1, 2 over, so there's 2 electrons there. Okay, now we're done. Let's go across. We're to a new orbital now, but I still need to communicate that we're still in the second energy level, but this time now the p orbitals. And if you count over to neon, we got 1, 2, 3, 4, 5, 6 electrons there. Okay. And so we've got 2 plus 2 is 4, plus 6 is 10, and there's 10 electrons. So that is correct. That would be your electron configuration for neon. Okay, let's move to practice problem number 18. We're gonna keep going, guys, until we get all the way to the highest element on the periodic table. We'll be able to do any of these, and so stay with me. There's a little tricks coming up, and so we're just going to keep going until we get all the way through it. Okay, for practice problem number 18, part A, wants us to write the electron configuration for magnesium. Let's find it on the periodic table. It's right here, Mg. Okay, so we're going to start with the first energy level. We're in the s orbital, and we count across 1, 2. So we put 2 electrons there. Now we move down. We're in the second energy level. We're still in the s orbital, so I'm going to put an s, and 1, 2 electrons can fit there. Okay, now let's move across. We're still in the second energy level. Whenever you change orbitals, you still have to put the energy level. But now we're in the p orbital. This block is the p orbital. And we're 1, 2, 3, 4, 5, 6 electrons can fit there. So now we're done with that second row. We come down to the third energy level. So let's put a 3. Which orbital is this right here? Well, it's the s orbital. And if you count across till we get to magnesium, it's 1, 2. And so 2 electrons can fit there. And since we are all the way up to magnesium, that's where we stop. Circle it. There's our answer. Again, if you want to check, we've got to have 12 electrons. 2 plus 2 is 4, plus 6 more is 10, plus 2 more is 12. And so that's a good idea to check and make sure you've got the correct number of electrons. Okay, now let's go to sulfur. Maybe hit pause, see if you can get this one on your own. Alright, sulfur on the periodic table, it's right here. It's elements, the symbol is S. So let's write the electron configuration. We're starting at the first energy level, s orbital, 1, 2 electrons in there. So I put a 2. We come down to the second energy level. We're still in the s orbital, 1, 2 electrons can fit there. Okay, we're just going to fill it all the way until we get to sulfur. So let's go across, left to right. We're still in the second energy level, p orbital this time, and 1, 2, 3, 4, 5, 6 electrons. So I put a 6 right there. Okay, now I'm done with that second row. I come down to the third energy level, so I need to put a 3 here. We're in the s orbital, so I need to put an s, and 1, 2 electrons can fit in that orbital, so I put a 2. Now I'm going to come across again, just like we would read a book, left to right. I have to go all the way to the right. Okay, we've changed orbitals, so I still need to say that we're in the third energy level. So I put a 3. Now we're in the p orbital block, and we're 1, 2, 3, 4 until we get to sulfur, so there's 4 electrons in that 3p orbital. All right. That is the electron configuration for sulfur. Looks like it has 16 electrons. 2 plus 2 is 4, plus 6 is 10, plus 6 more is 16. We did it correct. All right, let's see if you guys can do this one on your own. Practice problem number 18, part C, for argon. Argon, guys, is over here, very far side of the periodic table. See if you can write the electron configuration for argon. Hit pause and see if you can do it on your own. Okay, we're always going to start from the beginning, so we're at the first energy level, s orbital, 1, 2 electrons, so we put 2 up here. Now let's come down. We're in the second energy level, still in the s orbital, 1, 2, so we've got 2 electrons. Come across. Now we switched orbitals, so I need to tell that we're still in the second energy level. We're still in that second row down, but now we're in the p orbitals, 1, 2, 3, 4, 5, 6 electrons. Okay, now we're done with that second row. Let's come down to the third. We're in the third energy level now, s orbital, and there's 1, 2. So 2 electrons there. Okay, now let's come across, left to right, just like a book. We're still in the third energy level, so I'm going to put a 3. Now we're in the p orbitals, and if we count across to argon, it's 1, 2, 3, 4, 5, and 6 electrons. Okay. That is the correct electron configuration for argon. Okay, so we've done it. We've built our electron configuration. I feel like you could do any of them up to 18 right now. But there's a lot more elements, so let's keep going. Okay, practice problem number 19. Part A is for calcium. Calcium on the periodic table is right here. See if you can do this one on your own. Hit pause, write it, and then once you have an answer, hit play and see if you got it right. Okay, we're going to build it from the very beginning. The 1 energy level, s orbital, and if you count across, 1, 2 electrons fit there. Okay, let's move down. Second energy level. We're still in the s orbital, and we got 1, 2. So 2 electrons go there. come across. We've switched orbitals now, so I still need to say that we're in the second energy level, but now we're in the p orbital. 1, 2, 3, 4, 5, and 6. Again, we're going to fill it until we get to calcium, so keep building until you get to calcium. Okay, so we're done with that second row. Let's come down to the third energy level. We're in the third energy level, s orbital, and how many across? 1, 2, 2 electrons there. Now let's go to the right, just left to right, just like you would read a book. Okay, we're still in the third energy level. We're in the p orbitals this time. 1, 2, 3, 4, 5, and 6. We're going to go clear across until we get to calcium, so 6 electrons there. Now we're done with the third row. Let's come to the fourth row, the fourth energy level. This is the s orbital. And how many across till we get to calcium? 1, 2. So I got 2 electrons there. Okay. So you can check yourself, and hopefully that is what you got for calcium. If you did it correctly. All right, now let's throw in a little bit harder one and see if you can do this one. There's a little bit of a trick to this one. Okay, so let me go through this one with you. We're going to write the electron configuration for iron. Let me show you where iron is on the periodic table. Its symbol is Fe, and its atomic number is 26. Okay, just like all the rest, we're going to fill it up until we get to iron. We're going to start with first energy level, s orbital, and 1, 2 electrons. Okay, we're done at the first row. Let's go down to the second row. Second energy level, s orbital, 1, 2 electrons. Okay, let's come across. We're still in the second energy level, but now we're in the p orbitals. 1, 2, 3, 4, 5, 6 electrons can fit there. Done with the second row. Let's go to the third row. We're in the third energy level, s orbital, 2 electrons can fit there. Okay, let's go left to right, just like you read a book. We're still in the third energy level, but now we're in the p orbitals, and 1, 2, 3, 4, 5, 6 electrons fit there. Now we're done with the third energy level. So let's go to the fourth. Fourth energy level, s orbital, and we've got 1, 2 electrons can fit there. Okay. Now this is where it gets a little bit, there's a little bit of a trick involved here. When we go left to right, like we would read a book, this energy level for this block of elements drops down to the third energy level. So we need to put that. Third energy level. And now if we look, we're in the d orbital here. The first time we've come to a d orbital, 1, so we can put a d. And now let's just simply count across again, 1, 2, 3, 4, 5, 6 electrons. All right, and that is your electron configuration for iron. Just a little bit of a new trick here. When you get to the d orbital block, you got to drop down an energy level. Now let me say this. This dropping down of an energy level only is for the d orbitals. Okay, so if I was to come across here, and at this point right here, now I go back up to the fourth energy level. So this is 3d, but this element would be 4p. So the only one that drops down is this block, the d block. Okay. Let's see if you can do this one on your own. You should be able to do zinc. Okay, let me point out where zinc is on the periodic table. Its atomic number is 30. So it's right there. Hit pause. See if you can do this one on your own. Okay, we're going to start at the first energy level, s orbital, 1, 2 electrons. Come down, second energy level, s orbital, 2 electrons, 1, 2. Keep going across. We're still in the second energy level, p orbital this time, 1, 2, 3, 4, 5, and 6 electrons can fit there. Now we're done with the second row. Let's go to the third row. Third energy level, s orbital, and 1, 2 electrons can fit there. Let's go across, left to right, just like a book. We're still in the third energy level, this time p orbital, and we've got 1, 2, 3, 4, 5, 6 electrons that can fit there. We're done with the third row. Let's go to the fourth. Fourth energy level, s orbital, and 2 electrons can fit there. Okay, now be careful. We're going to go across to the d orbital block, but it drops down to the third energy level. So you need to drop down to 3. We're in the d orbital here. And if we count across to zinc, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons can fit in the d orbitals. Okay, so there is your electron configuration for zinc. Very good. Okay, let's get to some more complex examples. So practice problem number 20 wants you and practice problem 20 part A wants you to write the electron configuration for krypton. Let me show you where krypton is. It's Kr. Its atomic number is 36. And so let's build it until we get to krypton. Okay, we're going to start with the first energy level, 1, s orbital, 2 electrons fit there, 1 and 2. We drop down, second energy level, s orbital, 2 electrons. Okay, we come across. Whenever we switch orbitals, we still have to say which energy level we're in. We're still in the second energy level. Now we're in the p orbital. 1, 2, 3, 4, 5, and 6 electrons can fit there. We're done with the second row. Let's go to the third energy level. We're in the s orbital, 2 electrons. Okay, come across again. Still in the third energy level, but now we're in the p orbitals. 1, 2, 3, 4, 5, and 6 electrons fit there. Down at the third row. Let's go to the fourth. So we're in the fourth energy level. S orbital and 2 electrons can fit there. Now be careful. We're going to the d orbital block, so that should remind you to drop down to the third energy level. D orbitals, and we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. Okay, now right here, very important to remember, the only one that dropped down was the d orbital. We're in the fourth energy level here, so when we go to this p orbital block, we're back up to the fourth energy level. We're in the p orbital block, and if you count across to krypton, 1, 2, 3, 4, 5, and 6 electrons are there. Okay, so there is how you do the electron configuration for krypton. If you wanted to check it, we better have 36 electrons. So if you count across your exponents, we'll add up to 36. Okay, let's do practice problem 20, part B, which is for strontium. I'm going to circle strontium, and I want you to hit pause on your video and see if you can do this one on your own. Okay? Then hit play once you're ready. All right, let's do it. So first energy level, s orbital, 1, 2 electrons fit there. Now we drop down to the second energy level, s orbital, 2 electrons fit there. Come across, still in the second energy level, but now p orbitals, 1, 2, 3, 4, 5, 6 electrons fit there. Now we're in the third energy level, s orbital, 1, 2 electrons fit there. Okay, now we come across, still in the third energy level, but now p orbitals, 1, 2, 3, 4, 5, 6 electrons fit there. We're done with the third row. Let's go to the fourth. Fourth energy level, s orbital, 1, 2 electrons can fit there. Now careful, we're heading to the d orbital block, so we got to drop down to the third energy level. D orbital, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons fit there. Now be careful, you now have to move back up to the fourth energy level. Remember, the only one that dropped down was the d orbital block. So when we go here, we're going to fourth energy level, p orbitals, and 1, 2, 3, 4, 5, 6 electrons can fit there. Now we're done with the fourth row. Let's go to the fifth. Fifth energy level, 1, 2 electrons can fit there. Okay, so that's all the way up to strontium. we have wrote, and we've been able to write electron configurations up to number 38 on the periodic table. So we're getting there. We're getting there. Okay, let's continue. Practice problem number 20 still, part C. This one is for silver. Let me circle where silver is. It's number 47. 47, and the symbol is AG. Okay. So hit pause. See if you can do this one on your own. Here we go. First energy level, s orbital, 2 electrons. Second energy level, s orbital, 2 electrons. Okay, move across. Still in the second energy level, but now p orbitals. There's 6 electrons that fit there, so 2p6. Let's go to the third row down. Third energy level, s orbital, 2 electrons. Okay, let's move across. We're still in the third energy level, p orbitals, and there's 6 across. Now we're done with the third. Let's go to the fourth. Fourth energy level, s orbital, and there's 2 across, so 4s2. Now be careful dropping down to the third energy level, d orbital, and there's 10 across in the d block, so 10 goes there. Now be careful here. We go back up to the fourth energy level, 4. We're in the p orbital now, and there's 1, 2, 3, 4, 5, 6 electrons. Okay, now we're done with the fourth row. Let's go to the fifth energy level. We're in the s orbital, and there's 2 across. Okay, now be careful again. We're heading over to the d orbital. That always drops down, so we're in the fourth energy level now. D orbital. And to get to silver, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 over, so there's 9 electrons. Okay. And that will be your electron configuration for silver. Okay, practice problem number 21. This is the last practice problem, and we're going to get to, you're going to be able to do all of them here. So let's start with uranium. Part A says, write the electron configuration for uranium. Let me point out where uranium is on the periodic table. It's clear down here. Atomic number is 92. So it's got 92 electrons. We're going to have to account for all of them. Okay, here we go. I'm going to write small here because we got a lot of electrons. So we're going to start with 1, first energy level, s orbital, 2 electrons. 1, 2. Go down, second energy level, s orbital, 2 electrons. Okay, come across. Still in the second energy level, but now the p orbital. And we've got 6 across. Okay. Let's see if I can fix that. Now we're done with the second row. Let's go to the third. Third energy level. Okay, s orbital. Count across. 1, 2. Come across to the right. Still in the third energy level, p orbital, and there's 6 electrons there, so 3p6. We're done with the third row. Let's go to the fourth. Fourth energy level, s orbital, and 1, 2 electrons fit there. Okay, now be careful. We're going to the d orbital block. So we drop down an energy level back to the third, d orbital, and there's 10 across on the d orbital, so we're going to put a 10 there. Now we're to this point. Remember, you gotta, for the p orbitals, we gotta go back up, because the only one that drops down is the d orbital block, so we're still on the fourth energy level. Now we're in the p orbital. 1, 2, 3, 4, 5, 6 electrons fit there. Okay, we're done with the fourth row. Let's go to the fifth. Fifth energy level, s orbital, and 1, 2 fit there. Let's come across. Going to the d orbital, so drop down, 4, d orbital, and we're 10 across again. So 10 goes there. Now at this point, we come back up to the fifth energy level, p orbital, and there's 1, 2, 3, 4, 5, 6 electrons that fit there. Okay. Now we're done with that fifth energy level. Let's go to the sixth. Sixth energy level, s orbital, 1, 1, 2 across, so 2 electrons fit there. Now, this is where it gets a little different. Do you guys see this asterisk right here? If you look at that asterisk, it's telling you to drop down, because barium, this element here, is element 56. It's saying that 57 through 70 is down below. So if you look here, 57, you have to drop down. And so we're going to go from 6s2, drop down. Now this is the 4th energy level. So we're going to put a 4 here. We're now in the F orbital. So put an F. And if you count across, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 electrons across. Okay, now we're at element 70. So if we want to go to 71, we got to come back up here. But we're in the 5th energy level. So 5. This is the d orbital. Okay. So 5 and then the d orbital, and there's 10 across still. So we're going to put 10. Now I'm going to start over here again, but now we're at the 5d10, so we're right here. We got to come back up to the 6th energy level. We're in the p orbital, and if you count across, 1, 2, 3, 4, 5, and 6. 6 electrons fit there. Okay, so now we're done with that 6th row. We need to go to the 7th energy level. So we're in 7th energy level, s orbital, and 1, 2 electrons fit there. Okay. Now be careful again. We're to this point where there's 2 asterisks. 88 was right here. It's saying that 89 through 102 is down below. So we're going to come down to 89, which is in the 5th energy level. So I'm going to put a 5. This corresponds to an F orbital. We're in the F orbital, so 5F. And if you count across to uranium, 1, 2, 3, 4. So I put a 4 up there. Okay, yes, that's getting really long. But that is how you write the electron configuration for uranium. If you added up all the exponents, it should add up to 92 electrons. Okay, let's have you guys do practice problem number 21, part B, which is for Einsteinium. Einsteinium, guys, on the periodic table, its atomic number is 99. So it's clear down here, 99. Okay, so see if you can build it, the electron configuration for Einsteinium. Hit pause, see if you can get it right before I show you how to do it. Okay. For this one, I'm going to go a little faster. We've got to fill it from the start. So there's 1s2, there's 2s2, there's 2p6. We're done with the 2nd row. 3s2, 3p6. We're done with the 3rd row. Let's go to the 4th row. 4s2. Okay, now we're to here. We've got to drop down 3d10. Goes all the way across. Now come back up to 4p6. Going to the 5th row. 5s2. Drop down 4d10. Okay, now we're to right here. Come back up to 5p6. We're done with the 5th. Let's go to the 6th. 6s2. Now be careful. Asterisk telling us to drop down, so we're at 4, F. There's 14 across. Okay. Now we're to here. We need to come back up to the 6th energy, to the 70, 71. Yeah, we're to the 5th energy level, so 5D, and we're to here, so there's 10 of them. 5d10. Okay. Now we come back up again to 6 because p doesn't drop down. 6p6. Okay, and so we're to right here. Now let's go to the next row. 7. We're in the s orbital, there's 2 electrons there. Okay, that double asterisks are telling us to drop down to the 5th energy level. So I'm going to continue it here. 5, and we're in the f orbital. And if you count across to Einsteinium, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So 5F11 is where you're going to end. Okay? So yeah, that's a lot, but there's where all 99 of Einsteinium's electrons would be found around the nucleus. Okay. Yeah, one final question here. Let's see if you can do practice problem number 21. Part C is for you to write the electron configuration for rutherfordium. Okay. Rutherfordium, guys, its atomic number is 104. And here's where it's at. RF. So take a second, hit pause, see if you can do this one, you can do any of them on the periodic table. And that's a good accomplishment. So see if you can do it. All right, guys, let's see if we can do it real fast. My board is kind of acting up. So 1s2, 2s2, 2p6. We're done with the second row. Let's go to the third. 3s2, 3p6. Done with the third row. Let's go to the fourth. 4s2. Now be careful. Drops down to 3d10. Right here, it comes back up to 4p6. We're done at the fourth. Let's go to the fifth. 5s2. Be careful. Drops down to the fourth. D10. Okay, so we're right here. Goes back up. So right here it goes back up to 5p6. So 5p6, we're right here. Let's go to the next row down, which is 6. So 6s2. Be careful, this is where the asterisk is telling us to drop down to 4f14. Okay. Now we're to 4f14, which is right here. Now we go back to 71, which is 5d, and there's 10 across for 5d. Now we're to here. Remember, we come back up to 6p6. And so we're all the way across to right here right now. Let's come down, left to right, just like you would read a book, to the 7th energy level. I'm going to start again right down here. So 7s, there's 2 across, so 7s2. Now be careful, we're to these 2 asterisks, which tells us to drop down to 5f. And if we go all the way across, there's 14 of them. Okay, so we're to right here. Now let's go back up to 6d. And if you count over 1, 2 to rutherfordium, there's just 2 more electrons right in that orbital. Okay. That is how you do the electron configuration for rutherfordium. Guys, if you can do that one, you can do any of them. Hopefully that helped you learn how to write electron configurations. This is going to be a big part of this chapter. We're going to build on this skill and learn orbital diagrams next time. So you absolutely have to know how to write an electron configuration to do that one. So good news, you've learned enough chemistry to do another worksheet in your student workbook. I would like you to get more practice with this. So if you could complete the electron configuration worksheet in the student workbook, that will give you more practice in how to write electron configurations. Hopefully that helped.